Hi, we're CampusCompanion, and so pretty much the motivation for our project is, I think we all know picking courses is difficult. There's tons of courses that you can pick from across the university, and really the experiences you have today are very impersonal. You can't really talk with an advisor, they're hard to get time with, so we tried to create a system to help solve that. So our goal, of course, was to create a system that was stress-free. It allowed you to pick, pick courses within that environment. Consider the unique things about you as a student is to help boost your academic success by aligning your courses with either your goals and objectives, and obviously something that has a deep understanding, in our case specifically, of U of T. So data collection, the first thing we had to do was, of course, collect a ton of data for courses. So we actually collected over 5,000 course listings. So this is an example of a course listing from the undergraduate and graduate level. This is the distribution for some of the classes, not all of them, based off of departments. So you can see we got hundreds from ECE, and history example had a really large number. On top of this, you can see the actual course distribution in terms of the number of words, the course description in terms of number of words. So you can see kind of the amount of context you can gain in terms of words for each of the different courses. And then on top of that, we had two other forms of data. So we had to create synthetic user data to actually test the model and make sure things were making sense. And we created personas and profiles to go along with those. And then we needed outputs for validation to make sure everything worked as we expected. In terms of our model and software, so this is a kind of 10,000-foot view of it. We have our first part, which is our LLM-driven user questions. So this is slightly different from normal LLMs where you ask the questions. In this case, the LLM is asking you the questions to gain information about who you are as a student. And it actually is allowed to ask follow-up questions, and it decides when it's gained enough information based off the prompts we give it about the student. Once it has that, it creates a student summary. It summarizes that into a database query that we use RAG for. In RAG, we have two options. You're either an undergrad or a graduate student, so we look at those course selections. After that, we take the student summary plus sort of a short list of courses, and we try and create a candidate set. So the idea of the candidate set is just using the course name, not the full description. So we give it more courses and allow it to do a quick narrow down first. We couldn't provide all of them in at the beginning because it's just too much context, because we were looking at 50 plus courses. Then we have the LLM generated recommendations based off that candidate set. So we take the top, I think 10 or 20, and then we add in the student context and the course context, generate the recommendations. We can also have the option of adding in files or transcripts at that point, and we generate recommendations, scores, and general reasoning. And then on the side is just the different tools that we use to achieve this.
Okay, so our quantitative analysis of the model starts with a consistency score for summarizing task. So here we put our synthesized profiles into a GPT acting like a student, which converts with our model and generate a summary of that student. The evaluator will compare the summary and the original profiles for the consistency score. So our model with GPT-4 achieved a score of 8.3, which means the summary aligns with the reference profiles. And here are two metrics for recommendation task. The first one is recall, which measures model success in predicting the student course choices. And the normalized distributed cumulative gain assesses the ranking quality. So here in our test, we generate and rank 5 courses to students who will take 3. And our model successfully predicted 37% of courses taken by students. That is on average 1 course per student. And as for NDCG, it's a score that ranges from 0 to 1. If the NDCG is higher, the more accurate our model is in ranking the relevance of these 5 courses. So as you can see, our model did well in ranking. And we built up a rating system. We rated over 30 different responses, and we rate them from 0 to 5. 0 means failure, 5 means excellent, and most responses are good, but sometimes model gave back bad responses because it doesn't understand course level.
So this is just quickly running through an example. So it starts you off, you can recommend courses, you pick your course at the bottom if you're undergraduate or graduate. It keeps prompting you for questions to learn about the degree you're in, the field of study, some of the interests that you're learning about. So you can keep adding questions, and it's going to keep kind of prompting you, getting more information about a few different pieces of information about you. So it's really up to the user to kind of answer to a certain depth of how much they want to provide in. You can also upload a transcript here. So you can see it kind of has a full nice conversation with you. It sounds like an advisor. That's kind of a part of the persona that we added for the companion. And then you can see here is a list of recommendations with a score and a reasoning for each of them. So these are all graduate courses that you might have been interested in. That's it.
Okay. So here is what we know. First, it's very hard for us humans to evaluate the course recommendation result because there is no absolute truth. And second, we found that GPT is very difficult for GPT to understand the year of study and the course level from the course descriptions. Also, our model lacks the training on real data set. At last, I'd like to mention that some factors like prerequisite data and unique degree requirements are ignored, so we may consider them if we do this project again. Thank you.